Okay. So tangent prime is secant squared of the argument times the inner function prime, which will be 1 over 2, the square root of x to the 4th minus 3, times the inner function prime, which is 4x to the 3rd. And the only thing you can do here is just simplify the 2 and the 4. And the x, don't forget the x, don't forget the x. I was just forgetting it. So dy equals secant squared, the square root of x to the 4th minus 3, and then multiplied. I can even put it in front. It should have been in front. It's better. Over the square root of x to the 4th minus 3 dx.
And so you always include dx in the answer?
So we talked about the fact that these are two different things. When I'm asked to find y prime, it's simply f prime. If I'm asked to find the differential of y, it has to be f prime dx. Yes.
Okay, because dy, or y prime equals dy dx.
Over dx, yes.
Yeah.
Yes, because f prime of x equals dy over dx, you cross multiply, and that's how you get the dy. As f prime of x dx.
Got it.
Very good. That's the answer. Anything else?
Can we look at 3.9 number 4?
3.9 number 4. Is that from Weber sign?
Yes.
Okay, very good. I have it. 3.9, 3.9, 3.9 related rates. View, number 4. Okay. Let's take a look. 1, 2, 3, 4. A streetlight is mounted at the top of a 15-foot tall pole. Very good. Oh, not good. So it's right here, and this is 15, yes, feet tall. Okay. A man 6 feet tall walks away from the pole with a speed of, okay. Okay, so he walks this way with a speed of 5 feet per second. So this is his distance. So dx over dt is 6 feet, no, 5 feet per second. Perfect. Along a straight path, how fast in feet per second is the tip of his shadow moving when he is 45 feet from the pole? Okay. We looked at a similar problem when a person was moving away, walking towards a wall away from a spotlight. Okay. So this time, when he is here, the tip of his shadow is here. When he is here, the tip of his shadow is here. I'm signifying his head. When he's here, the tip of his shadow is here. When he's going, I'm not going to graph it again because I don't want to mess up the graph. But when he's here, look what happens. The tip of his shadow will be here. So obviously the distance increases. Okay. So how fast in feet per second is the tip of his shadow moving when he is 45 feet from the pole? Okay. I'm going to denote this by W. And we are going to use similar triangles again. So here's the situation. So this is 15. He is, again, it said he was 6 feet. So this is 6. This is X. And this is W. And we are given, we're asked to find dw over dt when x is 45 feet. So careful, this is a very important process when you read the problem, try to understand, create the figure, understand the similar triangles, and so on and so forth. Okay, perfect. So one more time, 15 feet, 6 feet, he's moving away from the wall, and this hypotenuse will be initially this long, then this long, then this long, then this long. So we are asked to find at the instant when the person is 45 feet away from the wall or the building, whatever, from the pole, how fast is this changing? How fast is W changing? So we want to determine W over dt when x is 45 feet. Okay, so I have to find a relationship that connects 15 feet, 6 feet, x, and W. So let's see how we do that. I have make sure that I used everything. Okay, so I'm going to also call this y. And let's see what we come up with. I also know that w squared equals 15 squared plus y squared, the Pythagorean theorem. I also know that y minus x, I cannot really use that. Okay, so now let's use the similar triangles. How do I know that these are similar triangles? Because I see two equal or congruent angles and the common angle. So now the proportions will be written. Let's start with the common angle. The opposite of the common angle is 6 divided by the opposite in the big triangle, which is 15. The opposite of this is something I don't have. The opposite of this is, I'm going to use A, over the opposite of this, which is W. And what else I can use? So this is y minus x. Y minus x divided by y. From here, I need somehow to find a relationship between w and x only. W and x only. So let's see. W and x. And then here, I also have that a squared equals 6 squared plus y minus x everything squared. So y minus x times w equals a y. Okay. I see that y minus w is here. Y minus x is here. Okay, y minus x would be a y over w, and I'm going to put it here. So a squared equals 36 plus this squared, a squared, y squared over w squared. Okay. Y, w I want, 36 I want, but I don't want a squared in there. Okay, I can go back there. Okay. So this, then w squared equals 15 squared plus y squared. Yes, I can replace y squared by w squared minus 225. So I got rid of that. But I also need to get rid of A. So I do have, I'm closer now with the relationship. So I have A squared equals 36 plus A squared. I have W squared minus 225 over W squared. I'm closer. And can I determine A? A is a constant. I have to get rid of A. Let me see for a second if I have, when this is 45. When this is 45, no, I have to determine A somehow. Okay, so I have A squared W squared equals 36 W squared, multiplying both sides by W squared, plus A squared W squared minus 225. I did not expect that to happen. I want to get rid of A squared, but I didn't expect that to happen. So, one more time. This is, the X is along the straight path. Man 6 feet tall walks away from the pole with a speed of 5. Yes, so that's X. Yeah. I just want to make sure that I correctly identify the X. Then I have dx over dt, which is 5 feet per second, and a straight path. How fast is, in feet per second, is the tip of his shadow moving when he is 45 feet from the pole? Okay, so we have 15, we have 6. This is my X.
Ask something?
Yes, please, anything, yes.
I don't really know. I was just thinking, could you do something with the relationship? With like, so you have 15, and then the bottom line would be x plus whatever that smaller triangle's bottom line is. So if that's like, I don't know, give that a variable. So then,
You mean this piece?
yeah, because you know
That's
you
y
know,
minus x. This is y, this is x, this is y minus x.
Okay.
You can name it a different letter if that's what you want.
Yeah, I don't know. I just didn't know if there is a way to find the relationship between like 15 and y versus and 6 and y minus x.
Yes, that's what I'm trying to find. So this is x, this is y, this is w. So I do have the w squared equals 15 squared plus y squared, because it's the hypotenuse 15 squared plus y squared. This should not be that difficult. This should not be that difficult. This should be much more straightforward. So then 6 over 15 equals a over w and equals y minus x over y. That's okay. So I also have this relationship that says that 6, I will simplify this. So let me write it here. So we have 6 over 15 equals a over w. So the 6 over 15, when I simplify it by 3, I get a over w equals 2 over 5. So w equals, when you cross multiply, 2w equals 5a, so w equals 5 halves a. So we have that relationship. And so but I went a little bit in circles because these two went away. So I'm just checking why that happened. So I do have this relationship, which is a good one. Then a squared is 6 squared. Yes, y minus x squared. That's correct. That's correct. Okay, so we have a squared equals 36 plus a squared y squared over w squared that I have. Better to replace a from here actually, 2w over 5. So 2w over 5, everything squared equals 36 plus y squared over w squared times 4w squared over 25. And I need to express y in terms of x. That's the last thing I need, to express y in terms of x, to replace it here. And then differentiate. Because I don't want y. I don't want anything else but w and x in there. So I see from here. So simplify 2/5 equals y minus x over y. And from here I will get y. So I have 2y equals 5y minus 5x, or negative 3y equals negative 5x, or y equals 5/3 x. It looks complicated. I should have done this much easier. Okay, so I will simplify these two, and I will replace y by 5/3 x. Okay, so 4 directly, let me square, over 25 equals 36 plus 25 over 9 x squared over 25. So we had y squared, which was 25 over 9 x squared, and multiplied by 4. Okay. So these two go away. So I have that 4w squared over 25 equals 36 plus 4 over 9x squared. And finally, we will differentiate both sides, and that's it. So the left-hand side is 4 times 2, it's 8 over 25 w times dw over dt. This is 0. The right-hand side is 4 over 9 times 2x dx over dt. Okay, finally, dw over dt would be, I divide by 8w over 25, and this is 8x over 9 dx over dt. Okay, so then I will replace x. Of course, my computer went to sleep, so I will replace this. I have the information here, 5. I will replace this. I think it was 45. Yes, this was 45. And I have to replace w. Okay. So where are my relationships here? Because I need to replace w. W, yes. So w is the square root of 225 plus y squared. Okay, how much is y squared when x is 45? So y equals 5 times 45 over 3, 15. So this is 75. Yes, so 75. Good. So now I have all my calculations ready. So when x is 45, so dw over dt, when x equals 45 feet, that will be 8 times 45 divided by 9. I'll simplify and I get 5. Multiply by 5. The denominator 8 over 25, and multiply by this, which is the square root of 225 plus 75. Okay, let me see if I can. I like simplifying before I punch in everything in the calculator if I can. So dw over dt. So 5, that's 40. 40 times 5, 200. So the numerator is 200. Let's see the denominator. So 8 over 25 right? That's 40 times 5, correct? Correct me if I'm wrong. And this is the square root of 300, isn't it? So I flip the denominators, so 25 times 2 will be 50. And this is 880, the square root of 3. So my left computer turned itself off. What did they say about decimal numbers or digits, or what did they say? Let me see if I can wake it up. I think I can. What did they say?
It doesn't say for decimal.
If it doesn't say a decimal, we may have to enter it as the an exact. So so 500 divided by, in parentheses, 8 times the square root of 3. If it doesn't say, I may have to go back and check my calculations, because if it's not an approximation and I get an approximation, I may have to go back and calculate, perform my calculations one more time. Now, in the problem, I considered this. You can also consider this, right? This length. It's not very clear. So this is one thing that I was going to say from the very beginning. So are they talking about the rate of change of this or the rate of change of this? Because if they want to find the rate of change of this, the calculations will be shorter. I considered this, but it's not clear. A streetlight is mounted at the top, okay. A man 6 feet tall walks away from, so they may consider the rate of change of this. It's not clear to me. See, with the problem that we looked at in class was extremely clear. This was the person. This was the person, and this was the height that was changing. So it was dy over dt that we were asked to determine in such and such conditions. But this situation can be addressed in several ways, right? So the person is here, or the person, the same height, is here. So I can consider this as dy over dt, or I can consider this as dw over dt. So it's a little bit questionable, this particular type of problem, because it doesn't specify. So I know we only have 5 minutes, and I'd like to finish the problem for you. I will look at both situations, but it's not clear from the problem. If they want us to determine this dx over dt, because it's not going to be the same, or dy, because I already called this x. So let's look at that option. So 6 and 15 again. This is x. I'm going to call this y. So if they want us to determine dy over dt when x is 45, that's a different story. So I still have similar triangles, which is a much easier situation. So I have 6 over 15 equals y minus x over y. And I'm done. I thought the problem was more interesting, right? So 6 over 15, and then y minus x over y. And the problem is finished. So I simplify by 3, and I get 2/5. And this is y minus x over y. I cross multiply. 2y equals 5y minus 5x, or negative 3y equals negative 5x. So y equals 5/3 x, and I'm done. Both are functions of time, and this is nothing. So it's dy over dt equals 5/3 dx over dt. It's finished. So when x is 45 feet, I have 5/3 times, what was that, 5? So it's 25/3, but that's no problem. And the measurement unit, of course, is feet per second. I thought that the problem was more interesting. And that is what I think is more interesting, to determine dy over dw over dt. But this is just one line, which is fine.
I got 35 over 3.
5 times 5.
But no, I put it like I had already done it before and put it in. And
But you don't have the same information. The problem is different for each student.
True. Yeah,
You-
yep, the red numbers are different.
Oh, yeah. Yeah. If you have these numbers, it's 25/3 and you're done. It's just one line problem. But this was intriguing to me. This was much more interesting. But it's not clear. That's why I said it should be simpler, but it's not clear. That attracted me, to determine that. The rate of change of the hypotenuse, not the rate of change of this little piece, the horizontal. So, yeah. That is not interesting at all. But it should be clear, in my opinion. So, yeah. Nothing spectacular in this one. I was hoping for something more interesting. But thank you for bringing this up. So, but it can be interpreted in different ways. It can be interpreted as dw over dt, and it can be interpreted just dy over dt in that figure. Very good. Anything else?
No, I think we're good.
Any other problems that you would like to look at?